Graphing polynomial functions. Sketch each of the following. So we're going to look at example 1a. There's some key features to polynomial graphs that we need to make sure we always look at. So two of the key features are going to be the x-intercepts and the y-intercepts. So to find the x-intercept, we're going to let y equal 0. So we're going to say 0 equals x plus 1, x minus 1, x minus 2, and we're going to solve for x. So x would equal -1, 1, and 2, which you could probably visualize in your head and maybe didn't need to show. The y-intercept, you're going to let x equal 0. So we plug in 0 every time we see an x value now. So we get 1 times -1 times -2, and we get 2. So those are key points we must plot. So we're going to plot this as we go. So -1 is a key point, 1 is a key point, and 2 is a key point. Okay, other things to consider. I can tell that this is cubic because there's 3 factors. It also tells me that it's odd. Helps me with the end behavior. A cubic function is going to have an odd, so one arrow will go up, one arrowhead will go down. Now, because this is a positive equation, there's no negative sign in front here, we know that it's going to fall left and rise right. So the end behavior is going to help me with the graph as well. So I've got my x-intercepts in here. My y-intercept, I haven't plotted that yet. There we go. So if it falls left, that means at the last x-intercept, I know that it's going downwards. I don't need to draw this too far because I don't want to, have it go, off course. Rise is right. I'm going to go to my last intercept, and I know it's going to go upwards. Then I'm going to connect all these points. I know I've got a nice point here, the y-intercept. I'm going to go through here. Now here, you don't know for sure if this is going to go way down here, way down low. So if you want a little more accurate of a graph, you're going to pick a point between 1 and 2. So in this case, we're going to have to use a fraction, and we're going to test a point. So I'm going to test when x equals 1.5 or 3/2. So I'm going to plug in that as an x value, and then I'll know the y value. So this is a little trickier because we've got that fraction, so we didn't have a choice. So I'm going to plug in to my equation for x, 3/2 plus 1, 3/2 minus 1, 3/2 minus 2. All right, let's add these. So I'm just going to get a common denominator right away here. So we get 5/2. I'm going to change that to a common denominator. We get 1/2. And I'm going to change this to a common denominator. And I'm going to get -1/2. So let's multiply. So 5 times 1 times -1 gives me -5. 2 times 2 times 2 gives me 8. So at this 1.5, it's going to go only down to -5/8. So that's just a little past that halfway mark. So it's not going as far as maybe you would have thought. So that's how you can test any points that you're unsure of.